Plan books for my models are available at Amazon. The links are in the description. If you are building the big tower crane model, you will soon come across several sections where you need to use spiral cut wood dowels. Here's one that moves the cable carriage, and there are other spiral cut dowels that are used for boom mounting screws. There are also spiral cut dowels used for adjustable feet on the base, so the crane will sit level on uneven surfaces. And I even use spiral cut dowels on my latest model, which is a small skid loader. This is the jig that I developed to cut spiral cut dowels on my saw. It's a very simple jig. There's just a crossbar here which is sized to fit my table saw, and then there's a block of wood which has some holes drilled in it which are slightly larger than standard dowel sizes with a groove cut in the bottom. Before we can actually get to using the jig, there are a few things you need to know about cutting spirals and wood dowels. When I cut spirals and wood dowels, I like to have my groove width about the same as the peak width, which is about equal on this dowel here. On this one up here, you can see that the peak width is a bit wider than the groove width, but it still looks pretty good. There are two major factors that determine your groove spacing. The first of those factors is just the diameter of the dowel. That dowel diameter works in conjunction with the angle at which you set the jig. As a general rule, the smaller your dowel diameter, the larger the angle you're going to need to use. I have found through experience that I tend to use my 4° and my 8° angle plate quite a bit. I use the 4° to cut the grooves in this 3/4 inch diameter dowel, and I actually use 12 degrees to cut the grooves in the 1/2 inch diameter dowel. I will be showing how to cut spirals in wood dowels using 3 different kinds of saw blades. The first kind of saw blade is called a slotting blade. There are a couple of things that are unique to a slotting blade. The first of those is that there are no carbide teeth. This is just ground steel, ground hardened steel that's sharpened. So there is no exposed cutting edge that extends beyond the side. So you can push a piece of wood as hard as you want to into the side of this blade while it's spinning, and you will not cut anything because there's just simply no cutting edges on the side at all. You will also notice that there is a flat grind across the top of these teeth. That means whatever slot you cut is going to have a flat bottom. The second kind of blade is a metal cutting blade. A couple of unique things about this blade. Now this has the carbide teeth that you can see, and those carbide teeth do extend beyond the flat part of the blade a little bit. So you can push a piece of wood a little bit sideways into this blade and you will cut because there is that cutting edge that's beyond the flat part of the blade. You will also notice on these teeth that there is a flat grind across the top of the carbide tooth. The third kind of blade is probably the most common out there. This is just a standard crosscut blade that I have for my hobby saw. You can see it has the carbide teeth, which extend sideways out past the flat part of the blade, so you can take a piece of wood and push it in sideways through this and do some cutting. And you can also see that the grind on the top of the carbide teeth is angled and alternating. This is actually the first type of blade that I will show you how to do. The first thing you'll want to do is set your blade height. Now the blade needs to be high enough so that it protrudes about 1/8 of an inch up into the hole of whatever dowel you're going to cut. Next we put on the crossbar and we just position it so that we can clamp it down good to the sides of the saw table. Before clamping though, we will set an angle. Now I'm going to start out with 3/4 inch dowels, so I'm going to start with a 4° angle plate. And then I will position the jig to make sure that that saw blade is protruding up into the correct hole. And then simply clamp the jig down to the sides of the table so it won't move. To start cutting your spiral, you insert the dowel into the correct hole and you rotate it clockwise. Now this is so that the bottom edge of the dowel will be fed into the moving saw blade. It's important here that the dowel will turn freely. You don't want it to be sticking in the hole, and you also don't want to be trying to force the dowel through the hole or holding it back. You want to let the saw blade do the work of advancing your dowel through the hole. That crosscut blade is pretty narrow that I'm using, but By advancing it smoothly through that hole, it did cut nice, evenly spaced grooves. Now we're still using the same saw blade here, but I'm using a 1/2 inch diameter dowel, so I have increased the angle that the jig is set at to 12 degrees. Now I simply insert the dowel and rotate it through the hole. Remember, it's going clockwise, so the bottom of the dowel is being fed into the saw blade. And just like before, you want to make sure that the dowel turns nice and freely. You don't want to be pushing it through, and you don't want to be holding it back. As long as that dowel turns freely, you will get nice, evenly spaced grooves. Now we're going to move on to the metal cutting blade. This blade is about 1/8 of an inch thick, and I like the size grooves that it leaves better than the small crosscut blade. Just like before, we set the correct height of the blade and set the jig on it, and I'm going to start by using a 4-degree angle plate. As I start feeding this dowel through the hole, I can tell that the dowel must be a little bit oversized because it's tending to stick in the hole, and I'm having to force the turn a little bit. Now you don't want to do that, because this is what's going to end up happening. You're going to end up with unevenly spaced grooves if you have to try to force turn that dowel, or if you're pushing it or you're holding it back. If the dowel doesn't turn freely, you'll end up with that. This dowel turns much more freely through the hole. I probably should have checked that before doing the first one, but you got to live with your mistakes and do some practicing. A little quick sanding on the grooves, and you can see here we have nicely spaced grooves. They're a nice width, and that looks pretty good. Using the same saw blade, we'll now try this on 1/2 inch diameter dowels. I will reset the angle of the jig to 12 degrees, just like I did for the other saw blade. And then we'll just start rotating, feeding that dowel through. I know I'm hammering this nail pretty hard, but you've got to make sure that dowel turns freely. Don't hold it back, don't push it through, let it feed itself through. And then we'll just do a quick sand of the grooves, and we've got really nice looking spiral. It's nice and even. The third saw blade we'll use is the slotting blade. Now this is the easiest blade to use because it has those no cutting edges on the sides. You cannot push the dowel through faster than it wants to go, and you cannot hold it back. The saw blade will feed it through at the speed it wants to go. I'm cutting a 5/8 inch diameter dowel here using an 8-degree angle plate. Now once we take that dowel out, you'll see that the grooves are nice and evenly spaced, but they're a little bit too close together for my taste. There's not enough wood between those grooves. So I'm resetting the angle to 12 degrees here. The spiral is nice and even, but it's a little too far apart for me, so I'll probably recut this using the 8-degree angle plate. So to sum up, the slotting blade is the easiest to use, and I think it leaves the best looking grooves, but it's also the most expensive option. The metal cutting blade is much cheaper and much easier to get. I bought this one off of Amazon for like $7, and it leaves really nice looking grooves. This is about 1/8 of an inch thick. I don't know if they make a thinner one to do thinner grooves or not, but 1/8 of an inch seems to be working pretty well for me and all the things that I've needed. The crosscut blade is the most difficult to use. You'll definitely require the most amount of practice to get good looking grooves, but you can certainly get nice grooves with that blade. It will definitely take practice. So I recommend getting a blade like this if you can get your hands on it, because it's going to be much easier than this. It's very easy to accidentally shove a piece of wood sideways into a blade like this and get uneven groove spacing. So that is the usage of the jig. You will certainly need to make some angle plates. You'll probably have to play around with exactly which angles you like best. Again, I use the 4 degrees and the 8 degrees, and then the combo of the 12 degrees the most.